Hi, this is Chris, and today we're going to talk about finding the angle between two planes, which is something that isn't very complicated, but a lot of us probably forgot it because we haven't had to do it in a while, so it'd be good to review before the final this week. So first thing, we're looking at the equation of a plane, and we have to remember where to get the normal vector from. And it comes right out of the equation of the plane. You just take the leading coefficients of the x, y, and z variables. And it makes sense that you wouldn't have to use the 4 or the 1 in finding the normal vector or to relate the two planes together in terms of the angle, because it doesn't necessarily matter how big the plane is, because no matter what, it's going to be perfectly flat. So whether or not one of them is 30 times the size, the angle between them is still going to be the same, so that number at the end kind of drops out. So the normal vector 1 is equal to 5, negative 3, 1, and then n2 is equal to 1, 4, 7. So now, in the dot product, cross product, planes and lines in space chapter, we went through there was a slew of equations that we had to know and be able to apply. But only two of them used an angle of some sort, and that was the dot product and the cross product. And in this term, the dot product is what we're going to use to find the angle between these two. So we know that n1 dot n2 is equal to the magnitude of n1 times the magnitude of n2 times the cosine of the angle between them. And now we're looking for theta. So we're going to plug in, or we're going to solve this for theta. And you're going to get theta equals the cosine inverse of the dot product of n1 and n2 divided by the magnitude of n1 times the magnitude of n2. And now, some quick computations. The dot product is going to be 5 minus 12 plus 7, which is going to be 0. So theta equals the cosine inverse of 0 over, and then that's the square root of 29 times the square root of 28. But regardless of what that number actually is, it's going to be 0 over something. So I'm just going to leave this as 0 over the magnitudes to save time, because we know that the cosine inverse of 0 is going to be pi over 2. So in this case, theta is equal to pi over 2 radians, or 90 degrees. So a 90-degree angle between these two planes means that they are orthogonal to each other. Now, another way to do this is to test if the normal vectors are orthogonal to each other, which is, I guess, effectively what we're doing with this. So that's not really another way, that's just a different way to think about it. And the second question we're going to do, I didn't write down yet, I apologize about that. It is x minus 5y minus z equals 1. And then 5x minus 25y minus 5z equals negative 3. And then, so the normal vectors are going to be 1, negative 5, negative 1, and 5, negative 25, negative 5. Now, right off the bat, when you're looking at these vectors, you know that these two planes are going to be parallel, because the normal vectors are scalar multiples of each other. So 5 times n1 is equal to n2. And we know that if the normal vectors of two planes are parallel, the planes are going to have to be parallel too.